So this is how we add and subtract numbers in scientific notation. I've got some examples for you, and basically it's one rule and then one trick that you need to be on the lookout for, because sometimes it happens, sometimes it doesn't. Kind of like that invisible one for an exponent that we've talked about in previous lessons. Now, the number one rule is before you can add numbers that are both in scientific notation, make sure they have the same power of 10. So they both have to the third power, so we're good to go. That means that I can literally add the two front numbers together, the 1.1 and the 2. So 1.1 plus 2 is 3.1. Quick little review of elementary math. When you're adding and subtracting decimals, make sure you line up your decimals and put in zeros for placeholders if need be. So after you add up the front numbers, just keep the power the same, times 10 to the third. There we go, we're done. If we were to subtract, we would subtract the front numbers. Since it's adding, we add the front numbers. Other than that, it's exactly the same. Now, what do you do though if the power is not the same? So this is where it comes into that one rule. And usually they will not be the same. What you do is you go to the smaller exponent and you just add on to it however many numbers you need to make it equal to the other one. So since this is 3, we're going to add a 1 onto the 2, so that way they're both 3. Now, the issue is that however many numbers you have to add on to this 2, that's how many spots you're going to slide this decimal on the front number back to the left. So since we added on 1, we're going to slide this decimal back 1 spot, and this becomes 0.2. Now, I know this is bad scientific notation, but what that lets us do is it lets us pretend that basically these two numbers have the exact same exponent, and that lets us be able to add the front numbers of 1.13 and 0.2. So 1.13 plus 0.2, and again add zeros for placeholders if need be, and that's 1.33 times, hey, keep that third power that we had worked out between those two problems, and you're finished. So that's adding. Now, why can't we just flip this over into standard form and then get the answer in scientific notation after we're done? Well, you can, but when the exponents get up to about the 90th or 100th or 50th power, you really don't want to do that. So here we go, we're going to be adding again. This is power of 5, this is power of 2, so we need to add on 3. And that means we're going to be moving this decimal quite a bit. So we've taken this second number and we've transformed it into a power of 5, so that way it can be added to this first number over here. How do we do it? We added 3 to it, and we had to move that decimal 3 times back to the left. Now, when you go to set this up, make sure that you do a really good job of keeping your columns perfectly aligned, because remember, we've got to keep that decimal lined up. And now I can just put in the zeros for the placeholders here. Decimal drops straight down. And there we go, 1.10267 times 10 to the 5th power. Same thing that we've been doing. So when we take a look at subtraction, and we're almost done here, I've got only one more problem after this one. When we take a look at subtraction, it's the exact same thing. This is 100, this is 99, so I need to add 1 to it, which means this comes back 1 spot. So it's 0.18 times 10 to the 100th power now. And I can put the 0 in front of that decimal. Let's subtract the front numbers. Line up the decimal. I'm going to put a 0 there as a placeholder. What do you do when you run into this situation? Same thing you do in grade school, just borrow. So we get 2.12 times, since we had made both of them into the power of 100, we're going to keep that for the final part of the answer. Alright, so I think you've got the basic idea for adding subtraction. You know to make the powers the same, and you know what effect that does on the decimal. But sometimes you're going to run into this situation. Here we've got the same power, and I made this one really, really easy. So 8 plus 2 is 10, and then it would be times 10 to the second power. The problem is that you can't have 10 for your front number. It should be like, 9 point something, or we should slide this decimal back and make it a 1. So that's what's happening there. But just so we also understand, this is the same as 10 times 100, which is 1,000. And 8 times 100 is 800. And 2 times 100 is 200. So we know that the answer should be 1,000. And this is 1,000, but we want scientific notation. And so when you see that you've got 10 or higher on this front number, you just basically need to drag the decimal back to the left. And if you recall, we were dragging the decimal back to the left here and added on 1. In this problem, we dragged it back 3 times, and we added 3. So since we're dragging the decimal back to the left, we're just going to add 1. And it's going to be 1 times 10 to the third. So if you get a number that's bigger than 10, slide the decimal back to the left to make it fit with scientific notation and add on however many times you had to slide that decimal back. Hopefully you can figure out what you would do to your exponents if you slid it to the right.